Hello, so these are the notes for 9.4 on conditional probability. And we've seen conditional probability a little bit already. So we've looked at this in Venn diagrams, saying that the event of B is affected by the outcome of A. Then we've looked at this before in our Venn diagrams by saying that we're gonna, in that situation, if we had A and B, and we want to know the probability of A happening given that B happened, that would be the situation where we look only at circle B. And so then the probability of A happening only takes place in this bit here. So conditional probability, we're saying it's this happening given that this happened. So numerator, denominator. That is probability of A given B, A intersect B over the probability of B happening. And we read this part as probability of A given B. So if we have events that are mutually exclusive, well, if we think back to our Venn diagram with mutually exclusive, that means that those two events are completely separate from each other. A intersect B doesn't exist, it's zero, because either one of them happening doesn't affect the other. So in mutually exclusive events, A given B is equal to 0. If I rearrange this, I can multiply this to the other side, and the probability of A intersect B is the probability of A given B times the probability of B. So this is always true. Whereas with independent events, remember we said earlier that in independent events is A intersect B is probability of A times B. So this is only true for independent, and it becomes true if we look at this, A given B, well, if A given B, if it's independent, then the probability of A stays the same. It doesn't matter what the probability of B was. So A given B is just going to be the probability of A. Yeah? So if they're independent, the probability of A is always true. Notice independent and mutually exclusive are not the same thing. So A given B, it doesn't matter what happened with B, the probability of A will stay the same. And so that means that I can replace probability of A given B with probability of A. So probability of A intersect B is probability of A times probability of B. So this is only true when independent. So always true. When independent, this becomes true. Usually, probability of A intersect B does not equal, goodness gracious. Probability of A given B usually does not equal probability of B given A. And in the next videos, there's going to be clearer examples, I hope.